up the session.
That's very nice, Patrick. So yeah, I'll just say a few words before Patrick's introduction of Kathryn Franich. So thank you very much for being here for our second lecture of the Catalonian Hub, ISGS Hub. We are, as you know, we are organizing 4 lectures a year, and there's like the second one, and we are already preparing the third one. It is going to be by Renia Lopez, and she's going to talk about L2 interactional dynamics and gesture use. So, and also, keep looking at our webpage, because we also have like more local talks, like one by Patrick and Celia. So this is going to be next week also. So really happy to see you here and in the upcoming activities. So thanks very much. And Patrick can go ahead. Thank you.
Yeah, thank you, Pilar. So it's my pleasure to introduce Dr. Katie Franich for our second ISGS-Catalonia online lecture. Katie is an assistant professor at the Department of Linguistics at Harvard University, where she is also the director of the Harvard Fawn Lab, as well as an affiliated member with the Center for African Studies and a member of the Mind, Brain, and Behavior Faculty Initiative. In 2017, she defended her PhD thesis entitled The Interaction of Prominence, Rhythm, and Tone in Medʉmba at the University of Chicago. As such, she is a leading researcher in phonetics, phonology, and prosody, with a particular emphasis on the phonological systems of African tone languages, speech timing, and what's most relevant for us here today, the coordination between speech and gesture. The high quality of her research program shines through in numerous research grants that she's been awarded. That is 7 in the last 10 years. Very, very impressive. And also her publications in top journals of the field, such as Language, Laboratory Phonology, and Scientific Reports. Beyond her scholarly achievements, I would also like to highlight Dr. Franich's deep commitment to supporting the communities in which she works. Her fieldwork in Cameroon and other regions is built upon long-standing collaborative partnerships, and she has played an important role in creating opportunities for local scholars and students through training, research opportunities, and community-based educational programs. Her model of research not only advances scientific knowledge, but also contributes meaningfully to the promotion and celebration of the linguistic diversity and cultural richness of the communities that she engages with. And on a quick personal note, also, this talk has been a really long time coming after a train delay last summer in Barcelona forced us to reschedule this talk. So we're especially delighted to finally be hosting her today here and to open up this event to the wider ISGS-Catalonia community. So with that said, it's truly an honor to welcome her today. We're really looking forward to hearing her talk entitled Cross-linguistic Variation in Co-Speech Gesture Timing, Evidence for Grammatical Control. So thank you, Katie. The floor is yours if you can share your screen, and we're really looking forward to your talk.
Thank you so much, Patrick, for that lovely introduction. And as I'm sharing my slides, I'll just give one small piece of advice, which is to never, ever try to travel around or out of France on Bastille Day, because only bad things will happen. Like missing your talk because the train conductor is too drunk to drive the train. All right, so I'm going to enter into slideshow mode. All right. So thank you so much for inviting me to give this talk. It's especially wonderful to give it to this group, of course, since there are so many people who are interested in these issues. Just being able to talk to such a high concentration of people who know about gesture and who think about gesture a lot. I'm really looking forward to getting your feedback. This is new work. Some of it is under review right now, but it will be a long road, I think, before anything is actually out in print. So I'm very much looking forward to getting your thoughts. So the main questions for the talk are around this question of where co-speech gesture belongs in the context of prosody. And the more specific questions that I'll ask today are what aspects of gesture are universal and what aspects of gesture are more language specific. And sort of on this last point, to what extent do we need to make reference to something like grammatical control to explain patterns of gestural timing across languages? So I will just breeze through this because I know for this group, I don't really need to say much about it, but I'll define co-speech gestures as movements of the hands, arms, head, shoulders, eyebrows, different parts of the body that are crucially temporally coordinated to speech. We're mostly going to be focusing on the hands today, although we do have some work looking at eyebrows and head movements as well. Beat gestures traditionally have been the subset of co-speech gestures that have been tied most closely to prosodic structure, mainly because they are seen to be sort of generally non-meaningful, although more recent research sort of questions this idea. Clearly, they are conditioned by prosodic structure, and misalignment between beat gestures has been looked at in the context of speech perception as well. So some work has found that perceivers have a more difficult time perceiving what a word is if the co-speech gestures don't align in the way that they expect them to temporally. However, we know that all gestures at this point seem to have some level of prosodic import. And the reason that I'm bringing this up is that we're going to be looking at data from a corpus of sort of naturally occurring speech in which we are looking at all different types of gestures at this point. So we feel justified in doing this based on previous work, including by some of the people here that have suggested that there's a prosodic import to all different types of gestures, not just beat gestures. So we know that gestures align with prosodically prominent syllables cross-linguistically. And in addition to that, we see gestures undergoing sort of parallel processes of lengthening, for example, in response to both prominence and an upcoming and a prosodic phrase boundary. So in many ways, gesture seems to kind of shadow what's going on in the spoken language prosody. I'm going to focus specifically on this link between gesture and prominence. So the link, for example, in English, I had this example here when a person is speaking in English, two people are speaking in English, the first one might say, "and the petunias," and the second one says, "they're beautiful." We see that the beat gestures are aligning to the stressed syllables, and specifically the syllables in the phrase that bear the nuclear pitch accent. There are various different hypotheses about how this relationship between gesture and prominence arises. So the first one I will label the biomechanical hypothesis that has been explored in works by Wim Pauw and Susanna Fuchs. So they propose that this relationship arises due to this locomotor respiratory coupling, which entails this biologically grounded coordination between breathing and movement. So basically, when we are moving the arms or other articulators, this has implications for the way that we produce speech. So these limb movements are causing cascading impulses in the body, which can manifest as greater fundamental frequency in particular, as well as intensity in speech. So there's sort of an intrinsic link between movement, gesture-based movement, and prominence here. The second hypothesis that I'll bring up, I'll label the effort code hypothesis. And this is, as far as the gesture side of this, it has been articulated in the work of Ambrositis and House, 2022 and 2023, but it also draws in part on work by Carlos Gussenhoven, who proposed the effort code hypothesis as being this sort of biologically based effect that we see across different languages. So for example, things that are more informationally salient tend to be realized with higher pitch across different languages. One of the things that Ambrositis and House propose is that gesture may be a sort of extension of this hypothesis, meaning that gesture is sort of one other channel through which we can express greater effort in communication. So there are a couple of ways that we might possibly think about this hypothesis. Taking the sort of effort code hypothesis at face value, as a sort of biologically based phenomenon, we might expect similar kinds of effects to what are proposed by Pao et al. In that there's sort of a link universally maybe between gesture and higher fundamental frequency, for example, which is one of the hallmarks of greater effort, as I mentioned, across different languages. But it's also possible that languages could potentially co-opt this effort, sort of this relationship between speech effort and gesture in more language-specific ways. So it may not be the case that every single language shows the same correlates of effort in the same ways. It may be the case that languages can sort of express effort or maybe package effort in terms of their grammars in slightly different ways from one another, and that gesture could, gesture timing could be impacted by these sort of this variation across different languages. So there's sort of two ways to see that, and I'll get into the specific hypotheses in just a minute. Then there's the grammatical control hypothesis, which is the one that I'm going to advance here. And this is not necessarily mutually exclusive, I think, especially with the effort code hypothesis. I'll say more about that later. But basically, this is the idea that the timing of speech and co-speech gesture is language specific and therefore is something that needs to be learned. So something that can't be explained by a biomechanical effect or a purely functional effect either. This is something that is encoded in the grammar that actually has to be learned. So as far as the predictions that each of these hypotheses might make, the first one, the biomechanical hypothesis, is fairly straightforward. I think we can say that we would expect co-speech gestures should align with higher pitch and higher intensity across different languages with different typological profiles, if there is this intrinsic link between gesture and pitch and intensity. As far as the effort code hypothesis, as I mentioned, there are sort of two ways that we can interpret this. So in general, we would expect that co-speech gestures should align with more effortful or more information-rich parts of the speech signal. Information-rich in this, right, the usual way that that information is seen as in the context of the effort code hypothesis is in terms of information structure. And there's this link, as I mentioned, between pitch and information structure. So things that are sort of more informationally salient are expected to have higher pitch and potentially also be accompanied by a gesture. However, it could be the case that there are other aspects of informational richness that could also align to gesture. So for example, where the most phonological contrasts are realized in your language. For example, do we realize a greater proportion of contrasts sort of more around the onset of a syllable or around the nucleus of the syllable? These kinds of asymmetries might also play a role in determining how information is kind of structured over the course of the speech signal. And then finally, the grammatical control hypothesis predicts that the timing of speech and co-speech gesture should be language specific, that there are not necessarily going to be universal links between something like pitch and co-speech gesture, that there may be sort of more language specific ways in which we opt to time our gestures. So again, there may be some similarities here with the second version of the effort code hypothesis in that it's possible that there are functional pressures that lead to information being packaged in a particular way across different languages, and this actually gets carried over into the grammar, which then influences the timing of co-speech gesture. So there could be a connection there. So in general, when it comes to understanding speech timing patterns, cross-linguistic data has been really, really important for helping us to understand how to conceptualize these patterns of variation and how to situate them in the context of linguistic grammar. So for example, this paper by Cho and Ladefoged in 1999 provides this really great cross-linguistic survey of voice onset time across a number of different languages. And we find that languages vary quite a bit in terms of how long, for example, the period of aspiration is for a a voiceless aspirated stop. So it's not the case that we have a sort of universal link between this feature spread glottis and a particular numerical value that feature gets realized with. And instead, languages do this in particular ways. We also have similar data on segment durations cross-linguistically. So, for example, geminate versus singleton consonants. More recent work shows cross-linguistic variation in the scope of pre-boundary lengthening. So how many syllables back you begin lengthening in anticipation of a phrase boundary varies across different languages. And also some recent work that I've been collaborating on with some people at Yale looking at prominence-related lengthening, and that's going to be sort of relevant to the work today. So where in the syllable we see lengthening taking place under prominence. So is it the consonant that is most affected? Is it the vowel that's most affected? Or is it maybe both? So modeling these types of variation across languages has required us to think about a kind of grammatical approach to this. And there are sort of two general ways that we can think about the grammatical modeling of cross-linguistic variation and timing patterns. One is to say that there is a phonetic grammar that mediates between phonological representations and phonetic outputs. So in this case, the language-specific timing values of something like voice onset time are going to be specified directly and learned as these modal peaks, these statistical distributions that are learned by the learner in terms of acoustic and auditory patterns, and potentially articulatory ones as well. Cho and Ladefoged leave open the possibility that that voice onset time could potentially be modeled in terms of articulatory timing patterns. There's also the sort of articulatory hypothesis, I'll say, which says that articulatory gestures are essentially the building blocks of phonological representations, and the source of variation within these theories of these kinds of language-specific timing patterns comes down to coordination relations between articulatory gestures. Okay, so the timing of the oral release gesture and the glottal gesture, for example, the relative timing of those two gestures is going to be language specific. And coordination relations are essentially defined as a part of the grammar as basically two gestures happening in phase, happening at the same time, or happening anti-phase sequentially to one another, or there are a variety of other different coordination relations that can be specified depending on your specific theory here. I'm not going to sort of argue forcefully either way for one of these approaches, but I think there are some useful things that we can gain from looking at things from an articulatory gestural perspective here. In particular, it makes this perspective allows us to make some relatively more concrete predictions, I think, about the timing patterns that we might expect to see across different languages. So these are some kind of schematizations of coordination relations from Shaw et al. 2021, who look at variability in timing of onset consonant clusters versus complex onsets. So this would be the difference between like the word butte in English, where bia is a consonant cluster with a labial and a palatal gesture. Whereas in Russian, you have words that actually have a complex segment, which contains both of those gestures within a single representation. So what their goal was in this work was to try and tease out the potential phonetic basis for differentiating between consonant clusters and complex segments. And one of the things that they looked at was the sort of consistency of timing of different articulatory gestures in the face of variation, in the face of different types of variation that would be introduced to speech timing. Their hypothesis was that in the case of the Russian type single phoneme complex segment situation, that the labial gesture ba and the palatal gesture ya would be timed in synchrony with one another. and that in English, where you have a cluster type representation, that the palatal gesture would follow the labial gesture. So these would happen in sequence as opposed to being initiated at the same time. And the prediction here is not just that you should find, relatively close timing between the labial and palatal gestures in Russian versus English, but also that close timing should remain consistent as you are perturbing something like the duration of the initial consonant gesture. So what you see in these graphs is the duration of the labial gesture, the ba part of the bya sequence. And then on the y-axis, you see the intergestural lag time. So the time between the onset of the labial gesture and the onset of the palatal gesture. And what you can see is there are sort of two broad patterns, the one on the left and the one on the right. The one on the left-hand side is the pattern that we see for English, where as you are increasing the duration of the labial gesture, the timing of the palatal gesture is getting later and later because the palatal gesture follows the labial gesture. On the right-hand side of the graph, since the labial and the palatal gestures are thought to occur at the same time, it doesn't matter how long you make that initial labial gesture, we still see that the two things are going to be occurring right around the same time. So we don't see any change in lag as the duration of the labial gesture increases. And then the top and bottom just indicate, you might have your two gestures starting off at exactly the same time, or you might have a sort of fixed lag between them. Either way, you expect there to be no change in lag over the different durations of the initial consonant gesture duration for the Russian case, a complex onset, versus the English case where you have a cluster. So this is a sort of specific prediction that these kinds of articulatorily based coordination theories make that I think is sort of nice in terms of being able to set up additional kinds of comparisons to do for different types of timing and coordination phenomena, including co-speech gesture, which I will get to in a bit. So the central hypothesis that I'm going to be testing today is that if co-speech gestures, like speech, are subject to grammatical control, then we expect principal differences in the behavior of co-speech gesture timing across different languages. That's the sort of core argument that I'm going to make, is that languages behave differently in terms of how they time their gestures. The specific languages that I'm going to be focusing on are these. So we have two varieties of English, US English and Cameroonian English. And then we have two Grassfields Bantu languages, Babanki and Medʉmba. These are languages that are spoken in Cameroon. They are tonal languages. So US and Cameroonian English are similar to one another in that they are, Cameroonian English, when I say Cameroonian English, what I mean is a variety of English that would definitely be mutually intelligible to people in this room. So there's also Cameroonian Pidgin, which is really its own language that is not, would not be intelligible to most of us, but there is a variety of English spoken in Cameroon that is more similar to the variety that I'm speaking right now. So these are both stress-based varieties, and from what we can tell, there is sort of an intonational grammar that in Cameroonian English that is relatively similar to what we find in English, in US English. So, there's an inventory of pitch accents that align to relatively more prominent syllables. So in that way, they sort of pattern similar to each other. Babanki and Medʉmba, on the other hand, being lexical tone languages, obviously use pitch in a very different way. So you're contrasting between different lexical items. There's very little evidence that there is a strong use of intonational patterns outside of the lexical tonal phenomena. So we do see, for example, a process of downstep getting blocked in focus constructions. There certainly are some sort of pitch-related phenomena that could be interpreted as intonational phonology, but we don't have the same sort of inventory of pitch accents for marking information structure that we have in the two varieties of English. Instead, you have things like focus markers doing a lot of work. So there's also syntactic patterns that can help us to mark information structure. The other thing about the Babanki and Medʉmba languages is that we have this aerial pattern of what's called stem initial prominence, meaning that it's the initial position within the stem, so the sort of unit that is the word minus all of its affixes. The initial position in that unit seems to play an especially important role when it comes to marking prominence, and I'll show you some examples of that in a moment. I also want to highlight the fact that in this study, the Cameroonian English and Babanki speakers were actually one and the same. So these were bilingual speakers that we elicited data from separately in each of their languages. So we'll also be able to get a glimpse of how bilingual speakers vary their gesture timing across their different languages. So I mentioned this phenomenon of stem initial prominence, which is a common phenomenon that we see in a lot of Niger-Congo languages, in particular across this region known as the Macro-Sudan belt. So this is sort of the northern part of sub-Saharan Africa. And what the sort of hallmark of stem initial prominence is that in the initial position of the stem, as opposed to non-initial positions or affixes, we see a much larger range of both consonantal and vocalic contrasts being realized in that position. So I'll highlight a few languages here, including Babanki, one of the languages that we'll be looking at in the study today. You can see that in stem initial position, the purple column here represents consonants that can be realized in that position. So you can get 24 different consonants in stem initial position for Babanki, whereas the next column over, the teal column, non-initial consonants are only 7 to 8 different contrasts. So there's a big asymmetry there in terms of what you can realize on initial versus non-initial consonants. And then we have a similar kind of asymmetry when we go to the stem initial versus non-stem initial vowels. So 10 different vowel contrasts realized in stem initial position, but only 2 realized in non-initial vowels. So this is the sort of one clue that stem initial position may be playing a particularly important role in marking prominence in this language, as opposed to pitch and duration that we would expect from a language like English. So the geographical distribution of stem initial prominence, just to sort of show you where it is, the Macro-Sudan belt would extend all the way across Africa, but this is actually a somewhat more limited region where we see these patterns of stem initial prominence, especially over here in the western part of Africa. And Cameroon is, I don't know if you can see my pointer here. Can you see my, yeah, okay, great. This is Cameroon here with the smokestack. So you can see it's like squarely in that zone of stem initial prominence. We find a lot of languages that follow that pattern in this area of the world. So here's some patterns from Medʉmba, the other Grassfields Bantu language that I've done a lot of work on. So you can see here we have a huge asymmetry. Depending on how you count different consonant contrasts, this number can vary. So for example, whether you want to see prenasalized segments as being separate, as being complex segments versus clusters, for example, this could affect what these numbers look like. But no matter how you slice it, basically you find a really big asymmetry here in terms of the number of consonants and vowels realized across stem initial position versus stem medial position, stem final position, and then prefixes and suffixes. You can see that there's a really reduced set of vowel contrast realized in those positions. So in some of my previous work, I have argued that this phenomenon of stem initial prominence, at least in Medʉmba, is actually better seen as foot-related. So this is based on metrical patterns as opposed to the stem per se. So in particular, so we can take this this phonological process, which is a lenition process that is responsible for some of the reduction in contrast that we see in stem medial position. So k going to r intervocalically. You can see that we get that pattern of lenition occurring within a stem. So on the non-initial stem consonant in the verb release, we get kara as opposed to kaka. And then we also get it before an enclitic that begins with a vowel. So the form karam has lenition internally as well. We don't get lenition if we have two separate prosodic words. So this word release preceding the name ange, we don't have a lot of vowel initial words in this language, so I've had to resort to names in some cases. But you can see that we get carange as opposed to carange. And then similarly, if we look at a prefixed form of this word release, if we take a CV prefix and add it to the beginning of the word, we retain the k form as opposed to leniting it, even though we have the intervocalic position. Because this consonant is occurring in stem initial position, it does not lenite. So stem initial position is sort of protected from this process of lenition. And then in this same paper, I draw on some additional, because these languages tend not to have very long words, testing for things like metrical structure becomes a little bit tricky because you don't have, the 3, 4, or 5 syllable words that you would ideally want to have in order to look at alternating patterns of lenition. But we have a parallel process in loan words that applies in Medʉmba. So in this case, it takes t and ch and turns them to sa intervocalically. And this is this actually occurs only in front of a high front vowel. So you can see the words in A here are realized with t initially. So t, the word for T is borrowed as T as opposed to C, and the word for Taylor is borrowed as tilo as opposed to silo. However, if we look at what we would expect to surface as a T in medial position in the word Saturday, for example, instead of getting something like Saturday, we get saside. So we get lenition of T here. Similarly for kitchen, instead of kichimi, we get kisimi. So lenition of cha to sa in that second syllable position. And then similarly for church, instead of chochi, we get chosi. Finally, in group C, we can see that if the T from the loan word is occurring in the final position of a trisyllabic word, we still retain the T. So instead of kubasi, we get kubati for cupboard, and we get libati instead of libasi. Okay, so we get lenition on the second syllable of a trisyllabic word, but not the third syllable of a trisyllabic word. And we also don't get it in initial position. So one way of accounting for this is to analyze these words in terms of foot structure and basically say that lenition is targeting the non-head position of a foot, assuming that these are trochees. We have lenition available here. We have initial lenition available here, but we don't have lenition available for the final syllable of kubati or for libati, because these are in the initial position of a foot. So just to sort of sum up, we find these patterns of stem initial prominence in Medʉmba, and I have reanalyzed these essentially as metrical patterns, sort of akin to what we would have for stressed versus unstressed alternations in English. So there's a sort of similarity there, I think, in terms of what this process is doing in Medʉmba. So here we can look at some data from what's happening with gesture in Medʉmba. And this is from a recent paper with my colleagues Herman Kupcho and Vincent Nwosu. We can see that stem initial position is also the position to which gestures are being attracted in this language. So stem initial position is much more likely than non-initial position in the word to attract a gesture, which is sort of on par with what we know about other languages preferring gestures to occur on metrically prominent syllables. So yeah, there's Herman and Vincent. Now I want to shift over to talking about this this phenomenon of consonant emphasis. So this is a phenomenon. Basically, I have talked about stem initial prominence, right, as this phenomenon where we see greater numbers of consonants and vowels realized in stem initial position in the words in languages that have this effect. A subset of those languages have been examined for this, this phenomenon of what's called consonant emphasis. This is a term coined by Idiotov and Van de Velde, 2017, who noticed that in a lot of these Niger-Congo languages that also display stem initial prominence, focus tends to be cued through relatively longer onset consonant duration of stem initial syllables, as opposed to vowel duration, as we would expect for languages like English. So here you have a prefixed word, mamama. This is from Iton, which is another Cameroonian language. And you can see that the duration of this is the stem initial consonant here, is considerably longer than it is for the stem medial consonant here, or than the prefix consonant here, even though this is the same ma consonant. The vowel, on the other hand, the stem initial vowel, does not actually undergo very much lengthening. It has a pretty similar duration to what we find for the stem final vowel and for the prefix vowel. So this was under contrastive focus that they elicited these forms. This is where they're seeing the increased duration showing up as when a word is contrastively focused. It's the onset consonant of the stem initial syllable that's getting this additional kind of lengthening. So the vowel stays relatively similar. The onset consonant gets the sort of boost. So there's sort of a link between these phonetic facts that we see for the consonant emphasis and the sort of stem initial prominence facts, where you have this greater number of consonants and vowels realized in that position. So there is a potential functional motivation for consonant emphasis in Grassfield's Bantu languages and related languages like Iton. They have a relatively high consonant to vowel ratio, meaning that the number of consonants is relatively high in the language relative to the number of segments that the language has, contrastive segments that the language has in general. However, there are many other languages that have relatively high CV ratios that don't show this pattern of consonant emphasis. So it seems to be the case that this is actually a fairly special phenomenon in this group of languages, one that we don't actually see in very many other languages of the world. I looked at, there's a really nice paper by Matt Gordon and Timo Rodiger that looks at correlates of stress across a whole bunch of different languages. And they do catalog some languages in which consonants, onset consonants, can undergo lengthening in addition to vowels, but pretty much in every language that they look at, if there's lengthening on the consonant, there's also lengthening on the vowel. So something that sets these languages apart that I'm talking about today is that it's really just the onset consonant and not the vowel that gets most of the lengthening. So in terms of a gestural model of consonant emphasis, from drawing on tools from articulatory phonology, this idea of a pi gesture or maybe a mu gesture would be the better fit here, some type of a clock slowing gesture that in the case of Medʉmba and Babanki would be expected to scope essentially over the onset of the stem initial consonant, whereas for English we would expect this gesture to extend over the onset and vowel, mostly the vowel, which is what is going to get most of the lengthening here. So different patterns of prominence, both at the sort of phonological level and at the phonetic level, are expected for Medʉmba and Babanki based on where they are situated typologically. So the question today that I want to ask is, to what degree do co-speech gestures also show language-specific behavior in their timing relative to the syllables? So just as I've shown that there can be variation in terms of prominence-related lengthening across different languages in terms of whether your consonants or your vowels are doing most of the work, do we also see kind of parallel effects in terms of the timing of co-speech gestures across different languages? And then what implications might these differences have for prosodic typology in general? So returning to the languages that I'm looking at today, we have, again, these two varieties of English, and then we have our two Grassfields Bantu languages, Babanki and Medʉmba. And again, the Cameroonian English speakers are the same speakers as the Babanki speakers, rather, in this study. This study involved 6 speakers each for each of the languages that I mentioned. They were gender balanced within across the different languages. The age range was between 21 and 54 years. They were video and audio recorded describing aspects of their family language history, their culture, and their relationship to the different languages that they spoke. And then audio data were transcribed and force-aligned at the word and phone level using Fave-Align, and then subsequently checked for alignment accuracy. When it came to the gesture data, basically we start by hand coding the gestures in terms of the various phases, the preparation, the stroke, the hold, and then the measure of the apex that we're going to be using in this work is going to be the minimum velocity, or the point where the hands are maximally extended. So we're focusing just on the hands. The specific, the measure of the apex, we actually, so we coded the preparation, stroke, and any holds manually. We had students doing this work, and they worked in pairs to establish intercoder reliability. And then from the strokes that they had marked manually in the data, we used an automatic method using markerless motion capture to pull out this measure of the minimum velocity, okay, for our apex measure. So basically looking within that window of time allocated for the stroke that the students had marked, we're looking for the point of minimum velocity, specifically of the usually the right wrist, or the dominant wrist of the participant. And we did compare different methods here. We compared with like the dominant index finger. We found that the wrist actually gave us the least noisy measures here. So the predictions are that if co-speech gestures mirror prominence in showing language-specific differences in terms of the fine timing of prominence within the syllable, we expect gestures to occur earlier within the syllable in Babanki and Medʉmba relative to English. If differences, on the other hand, in gestural timing are related potentially to areal factors, we might expect that Cameroonian English will behave sort of similarly to the Grassfields languages. So if there are kind of areal influences on the timing of gestures, we would probably expect the Cameroonian English speakers to show similar patterns in Babanki and Cameroonian English. So here are the results as far as apex timing within the syllable across the different languages. So we have Medʉmba on the top, then Babanki, Cameroonian English, and US English. And the colors correspond to the part of the syllable. So the blue is going to be the onset, the green is going to be the nucleus, and the red is going to be the coda. And then we have the proportion of apexes that were present on those different parts of the syllable. So you can see that in general, the Medʉmba and Babanki speakers had more apexes occurring within the syllable onset compared to speakers of the two varieties of English, who these two groups actually pattern very similarly to each other in terms of the overall distribution of apexes within the syllable. We find, so there was a significant difference across the language groups. We did find also that there was significantly more alignment for Babanki speakers within the nucleus of the syllable compared to Medʉmba. So Medʉmba had slightly more onset alignment than Medʉmba, but on the whole, Babanki and Medʉmba both had significantly more onset alignment than English. So here's another graph of our apex timing results. So, oh, you know what? I realized I accidentally copied the wrong plot here. So these are the same plot. They should be different, obviously, because they're two different languages, and I meant to fix this and forgot. But in any case, the Babanki data doesn't look exactly like English, but it looks very similar to it. In that, the histogram is representing the distribution of apex timing. The dotted blue line is representing the onset of the vowel. So in both Medʉmba and Babanki, we see that most of the apexes are occurring before the vowel onset. Whereas if we come down to Cameroonian English on the left bottom and US English on the right bottom, we see that most of the apexes are occurring after the vowel onset. And this is consistent with the idea that the apex is occurring around something more like the pitch peak of the syllable as opposed to the onset. So when it comes to these apex measures, there's a little bit of ambiguity here in terms of how we should interpret the data. So if languages show universal timing of gestures relative to the word and syllable onset, then apex distribution may simply reflect relative durations of the syllable onsets across these languages. So we know that Medʉmba and Babanki have, on average, longer syllable onsets than English does. So if there is some universal kind of anchor point across these languages, if people are timing their gestures relative to word onsets, for example, it could just be an accident that we end up with a bunch of apexes during the onset for the grassfields languages and more during the vowel for the English varieties. So we're going to look a little bit deeper to sort of confirm that these patterns are actually meaningful and not just a sort of artifact of the different relative durations of syllable onsets across our languages here. So here we're looking at the onset of the stroke, so the beginning of the sort of intentional part of the gesture relative to the word onset. And you can see US English is in red, Cameroonian English is in green, Babanki is in blue, and Medʉmba is in purple. And we do see a significant difference across our language groups in terms of timing. So in particular, we see that speakers of Medʉmba and Babanki tend to initiate their strokes before the word has begun, whereas, so hence the negative values for these two bars here. And the US English and Cameroonian English speakers tend to initiate their strokes a little bit after the word has begun, but right around the word onset. And then just to sort of make double sure that it was not something about the nature of onsets across these different languages that could be driving these effects, we looked at a more constrained set of data that it was just the vowel initial words across our four languages. So this is all words that just begin with a vowel, and these are all monosyllabic words, I should say, as well. And here we see, again, a significant difference across the English varieties and the Grassfields Bantu languages in terms of timing. So on the whole, but Medʉmba and Babanki speakers are initiating their gestures earlier relative to word onset compared with our English speakers. And there is no difference between the two varieties of English in their patterning. So I'm going to return to this idea of trying to sort of like think about articulatory landmarks in this way that I sort of set up earlier. This idea that we might be able to understand better which articulatory landmarks or which landmarks in general, phonetic landmarks, gestures are timed to, if we look at the relative timing of gesture and these different landmarks in the context of variability that we introduce to the timing. So the variables in particular that we're going to be paying attention to, so the Shaw and Gafos 2015 proposed that basically understanding the temporal coordination patterns between two landmarks is going to require two things. First is the identification of what they call essential variables. So these are the variables that the gestures in this case are actually meaningfully timed to. So we have gesture apex timing to pitch peak, which is of course something that has been replicated in many studies of English and related languages. And then we also have gesture apex to the acoustic vowel onset. And the reason that I'm choosing the acoustic vowel onset as another essential variable here, and in particular, the hypothesis is that the Grassfields languages should show closer alignment of the gestures to the vowel onset, comes from our empirical observations that we tend to see gestures occurring right around that point in our data. The non-essential variable in this case is the variable that we are kind of perturbing in order to observe the relative stability of the timing of our essential variables. So the non-essential variable in this case, the one that I had showed you from the example with the BIA sequences, was the duration of the initial consonant gesture. In this case, we're going to be looking at the acoustic duration of the syllable or word onset as our non-essential variable. So the idea is, as we increase the duration of the onset consonant in the word, how does this influence the relative timing in any of our languages between, on the one hand, the gesture apex and the pitch peak, and on the other hand, the gesture apex and the vowel onset? And the prediction is that as we perturb this non-essential variable, we should see more variation in timing between apex and pitch peak for the two Grassfields languages, for which we don't predict there to be an essential relationship between gesture apex and pitch peak. And on the other hand, we expect to see greater variability in lag times between gesture apex and vowel onset for English, the English varieties, as we increase the duration of this non-essential variable, the acoustic duration of the word onset. Because again, for English, we don't expect that vowel onset and gesture apex are the sort of essentially connected variables. We expect that the gesture apex and the pitch peak are going to be more closely aligned. So here are the overall patterns of onset duration, relationship between onset duration on the x-axis here, and on the left-hand side, word onset to pitch peak, and on the right-hand side, word onset to vowel onset. As you can see, there is a relationship, a positive relationship between these variables. The non-essential variable on the x-axis and our essential variables on the y-axis in either case. However, the correlation between the vowel onset to word onset and pitch peak to word onset measures are not super highly correlated to each other. So this is another important thing, is that as we're trying to figure out what the essential variables are, we want to make sure that these variables are somewhat independent of each other, which we do find. So here are the plots of our individual languages here as far as how this non-essential variable onset, syllable onset duration on the x-axis influenced this lag time between apex to gesture apex to pitch peak on the left-hand side and apex to vowel on the right-hand side. So as you can see, as we increased syllable onset duration for US English and Cameroonian English, the lag time between the apex and the pitch peak did not change substantially. That relationship remained relatively constant as we perturbed syllable onset duration, which is what we would expect if it is these two variables, the gesture apex and the pitch peak, that are critically timed to one another. On the other hand, for Medʉmba and Babanki, as we increase that syllable onset duration, we see that the lag time increases for both languages. Okay, so less stability in the face of that perturbation for the apex to pitch peak lag time for those languages. If we come over here and look at the apex to vowel timing lag measure, we find basically the exact opposite pattern. So as we increase syllable onset duration, the apex to vowel lag time decreases in value across US English and Cameroonian English, whereas it remains relatively stable for Medʉmba and Babanki. Okay, so as we perturb this non-essential variable, the lag time is stable for Medʉmba and Babanki, but not for US English and Cameroonian English, which again is consistent with the idea that the essential variable to which our gestures are being timed in Medʉmba and Babanki is the vowel onset as opposed to the pitch peak. And just to further, like if there was any doubt as to whether it is the case that the gesture apexes in the Grassfields languages are actually timed to pitch peaks, I've plotted out here for Babanki on the left side and Medʉmba on the right side by tone, by lexical tone. So we have falling, high, low, and rising. Note that for Babanki, we don't really have very many contour tones showing up, whereas for Medʉmba, we have more contours showing up. If it were the case that the pitch peak and the apex, gesture apex, were consistently being timed together, we would expect these lines, the red line is the apex to word measure, and the blue line is the pitch peak to word measure, to pattern together. But what you can see across these graphs is that they very much don't. Okay, so whereas the apex to word and pitch peak to word measure were fairly close for high tones, as we move from high to low, these differences actually diverge from each other. So what this suggests is that you know, there's just not a close relationship again between pitch peak and apex in these Grassfields Bantu languages. So in summary, co-speech gesture apexes are more likely to occur during the syllable onset in Medʉmba and Babanki versus US or Cameroonian English. And this difference reflects differences in the timing that's observable even before words begin. So we can, you know, the fact that people are initiating gestures at different timing, you know, before they have even begun to utter the word in some cases, I think is quite striking. The US and Cameroonian varieties pattern very similarly. I was sort of surprised by how similarly they actually pattern to one another. I was kind of expecting that we were going to have some sort of like middle ground maybe for the Babanki speakers, but really in pretty much every way, the Cameroonian English data pattern very similar to the US English data. So one possibility here is that co-speech gestures could actually even constitute the sort of like physical instantiation of the pi or mu gesture, this clock slowing gesture, which I think is an intriguing thought, given that, you know, this is one of the only types of gestures that's proposed in articulatory phonology that doesn't actually have a sort of physical manifestation. So unlike, you know, a lip or tongue gesture, the clock slowing gesture is a much more abstract notion, right? But if we could actually tie co-speech gesture to the, if co-speech gesture is essentially marking off the onset to offset period of the pi or mu gesture, this actually may give us some sort of like physical instantiation that is available at least some of the time. Of course, we can apply these clock slowing gestures in the absence of a gesture, a co-speech gesture. But I think it's intriguing that we seem to find such close alignment between what the hands are doing and what the slowing effects are. This actually sort of brings up a sort of chicken or egg question, I think, in that, so I've argued that prominence and gesture occur earlier in the syllable in Medʉmba and Babanki due to a difference in the timing of the onset of the pi gesture or the mu gesture. But another possibility that's maybe not mutually exclusive with this is that gestures themselves are inducing some level of durational lengthening. And we've actually shown in our lab that if you can control as much as possible for differences in the pragmatic context, you still find that the presence of a co-speech gesture leads to relatively larger articulatory gestures that are also longer in duration. So there could be a relationship there. And this is work from my recent postdoc, Carrie Garvin, where she did an Emma, we did an Emma study looking at the relative height, for example, of the tongue blade and the jaw during speech with and without co-speech gestures. And indeed, the tongue blade is lowered to a greater extent, you can see in the gesture condition than the no gesture condition. And these were sentences like, I saw the spobo today versus I saw the spobo today. So, you know, there's really no sort of like, we've controlled as much as we can for the pragmatic context there. And you can see on the right-hand side here, we also find a significant difference in the relative duration of syllables when they are accompanied by a gesture versus not. So kind of along those lines, I also just wanted to show a little bit of data on the effects of co-speech gesture on duration in our corpora, and how this also relates to aspects of information structure, such as new versus given information. So we have our 4 languages here, and duration in milliseconds is on the y-axis. We've got gesture versus no gesture marked at the bottom of the graphs, and then words that are being uttered for the first time in the corpus are marked with the solid lines, whereas those that have been previously uttered in the corpus are marked with the dotted lines. What you can see is that there are clearly effects of both factors, new information versus given, and gesture versus no gesture present in the corpus to varying degrees, right? So here in Cameroonian English, I think we see the largest interaction where for both the gestured and non-gestured syllables, we find longer duration for first mention versus previous mention. But you get an even bigger boost when the gesture is present, right? And across all the languages, we see that when a gesture is present, syllables are relatively longer. Of course, there are other aspects of information structure we haven't taken into consideration here. There could be effects of focus that are also impacting these duration results. But I do find that it's striking that at least taking this one measure of information structure into consideration, we still see that the presence of gesture seems to have this effect on duration. And maybe to sort of take it to an even more fine-grained level, this is kind of an annoyingly complicated graph, but I'll try to walk through what's happening here. So on the x-axis here, we have alignment of gestures in our so there's 4 different languages, again, US English, Cameroonian English, Babanki, and Medʉmba. On the x-axis, we have where the gesture was aligned within the syllable. So whether it was aligned to the onset consonant, whether it was aligned to the vowel, or whether it wasn't, whether there was no gesture at all. Okay, so the none category here is the absence of a gesture. And then we have duration on the y-axis, and then I've separated it into effects of consonant versus vowel. Okay, and you can see that when the gesture was aligned to the consonant in the syllable, the consonant was the thing that lengthened the most in the syllable, as opposed to the vowel, which didn't change much. When the gesture was aligned to the vowel in the syllable, it was the vowel that got the most boost in terms of duration. So we see this sort of very fine-grained effect in terms of the timing of the gesture on the timing of the segment to which it is aligned to. And of course, this could be explained in terms of differences in timing of prominence that may be influenced by things like the presence of a prosodic boundary. There could be a number of different factors that could be influencing the relative timing of prominence cues within the word. So I think it's, certainly something that we need to look into a lot more, but I think it's interesting that across all 4 languages, we seem to find this very close relationship between increases in duration and the timing of the gesture within the syllable. All right, so just to circle back to the hypotheses, the biomechanical hypothesis predicted that we should see co-speech gestures aligning primarily to pitch peaks across languages, regardless of their typological profile. And I think we find pretty clear evidence that that's not happening in our grassfields Bantu languages here. So I think we can say that at face value, the biomechanical hypothesis can't explain all the effects that we're seeing in Medʉmba and Babanki. As far as the effort code hypothesis, the first version of this, as I mentioned, is not so different from the biomechanical hypothesis in terms of its predictions. We predict that, relatively that if there is a universal relationship between effort and greater fundamental frequency, and gesture is just one other channel through which we are realizing this effort, that gesture should align to syllables with relatively greater fundamental frequency, which is not what we find. The more language-specific effect, this idea that maybe languages co-opt this sort of effort code in different ways, might actually be borne out in our data if we think about the fact that, as I mentioned, there's relatively high sort of density of consonants in these grassfields Bantu languages. And to the extent that a lot of the information about a word's identity is held within these onset consonants, this could be a reason to think that there's maybe a functional relationship between onset consonant and gesture, right? If the gesture is attracted to the point in the word that is doing the most work in terms of communicating contrast, then it might make sense that there's a relationship there. So maybe some evidence for a relationship there. And then finally, the grammatical control hypothesis, so the idea that languages are going to vary in ways that can't be reduced to either a biomechanical effect or a functional effect. I think we have pretty solid evidence at this point. So to conclude, the timing of co-speech gestures shows hallmarks of language-specific control at both the level of prominence, but also at the subsyllabic level in terms of where in your syllable prominence cues are the most dominant. Theories of prosodic grammar and learning, therefore, must account for prominence multimodally, okay? And of course, this is not a new proposal. Pilar's and co-authors have already been proposing this modality-neutral approach to prosody, which I think is very much in line with some of the findings here. And then finally, the potential for integration of co-speech gestures with articulatory gestures within articulatory phonological models of grammar, I think is really key here. Like adding in manual gestures to the overall picture is a fairly easy thing to do, right, within these types of models. And in fact, it may be helpful to do so because it allows us to sort of understand why this relationship between co-speech gesture and prominence exists, that co-speech gesture is essentially giving us the gestural cue for something like a pi or a mu gesture. And I will end there, and thank you so much for your attention.
Wonderful. Thank you very much. Very, very interesting talk and lots of things to think about. So maybe we should open up the